Are you ready for the last session of the day? We are thrilled to end the day with a career Ask Me Anything with one of the biggest names in AI and ML, the legendary Jeff Dean, Senior Vice President of Google Brain. Jeff Dean has earned himself celebrity status both at Google and in the larger computer science world. He's widely considered the mind behind MapReduce, Bigtable, TensorFlow, and many of Google's key engineering developments. What's lesser known is that when Jeff was finishing grad school, he was actually seriously considering a career in academia. Despite his aspirations, Jeff only received one academic interview and offer. So, what did Jeff do? He went into industrial research, and the rest is a very interesting and impressive history. Julia Elliott, Head of Partnerships at Kaggle, will be a moderator for this Ask Me Anything event. Thanks again to the many of you in the community who submitted so many great questions for Jeff. I will now let them take the floor.
Hello, everyone. Hello, Jeff. Thank you so much for joining us for this Q&A. Given your notable background, I'm sure this is one of the sessions that many of our CareerCon viewers are most looking forward to attending. It's also actually a personal honor to be hosting you. As the competitions lead for Kaggle, I've had the privilege of working with many of your Google AI teams and bringing their machine learning problems to our community, which are often addressing some of the most prevailing topics in ML. As Jessica introed, you've had quite the journey to where you are now. And so I'd like to start just by hearing a little bit more about your upbringing. What was your childhood like? Who were your greatest influencers and role models?
Sure. First, thanks for having me. So my childhood, I guess I had a somewhat unusual childhood in that my parents and I moved a lot. I'm an only child, and we ended up moving all over the world for various things. My dad, for the first part of my childhood, did tropical disease research, and then he switched to being a public health epidemiologist. And my mom was an anthropologist, and they all sort of enjoyed experiencing new places. And so I went to 11 schools in 12 years, including living in Hawaii, Boston, Uganda, Boston, Arkansas, Hawaii, Minnesota, Somalia, Minnesota, Atlanta, back to Minnesota for college, then summers in Geneva working for the UN, then worked there for a year after college before grad school, and then went to grad school in Seattle, and then I moved to the Bay Area, and I haven't moved since.
Well, that's quite the colorful background. So parents who are anthropologists and disease background, how did then your interest in computers begin? Where did it stem from?
So I guess when I was about 9, my dad at that time was starting to get interested in was doing public health related work, and was interested in sort of how computers could be used to collect and aggregate statistical data about epidemics and use that to make better healthcare decisions. Mm-hmm. At that time, computers were these giant mainframe things that were kept in the basement, and my dad was kind of frustrated because that was kind of a bad way of actually trying out things. It really wasn't very interactive or personal. And then he saw an ad in the back of a magazine for a kit computer. It was an IMSI 8080. So if you've seen these very early personal computers with like toggle switches on the front, so you could toggle in a few bits, and then you could toggle in an address, and you could set a particular memory location, and it had blinky lights on the front. And then we got like a keyboard and a screen, and that was a huge improvement because then you could actually type things. But I was like 9, so I was like a little bit young to really be involved, but I sort of watched him solder this thing together and sort of helped him a little bit. I've probably more got in the way. But that sort of about a year after that, I started getting interested in like writing computer games in BASIC because it had a BASIC interpreter and you could sort of start to program it. And I got this big book of a bunch of source code listings for games, and you could type them in and play them. And then you could sort of start to modify them to make different games, which was kind of fun.
Yeah.
That's really how I got started in programming.
Mm-hmm. And then, so then you went on to university where you did choose computer science as a major. Were you debating other options, or at that point were you pretty invested?
So when I started university, I really knew I wanted to do computer science. Along the way, I took some econ classes, and I like, oh, this is kind of fun. So I added a second major in econ. And I think that's been kind of useful. I sort of was debating going to grad school in econ, but decided computer science was much more practical and useful. And I was sort of better at that. So.
And so you loved it so much that you went on to get a PhD. How did you make this decision? I think some of our viewers might be deciding whether to continue on to graduate school or go straight into industry. Why not go straight into industry at that point?
Yeah, I mean, I kind of knew I wanted to get some sort of advanced research oriented degree, partly because towards the end of, like in my senior year, uh, uh, I took a class from a professor named Vipin Kumar at University of Minnesota um, in parallel and distributed computing.
Mm-hmm.
And as part of that, I kind of got a taste of parallel computing, which I thought was pretty interesting because you could bring more computation to problems than just on a single machine or single processor. And I also got introduced to neural networks in that work. So I then did an undergraduate research, kind of independent research project as a senior thesis with Vipin Kumar. And I kind of got a taste of doing research in that context. Actually, I recently discovered my undergrad thesis as a PDF. I had lost it, but the university library had tracked it down and sent me a copy. So I actually posted that. You can go find interesting, very old neural network work that I did. But I kind of got a taste of doing research, and I felt like I wanted a research career. And so I knew I wanted to go to grad school. I also decided I would take a year off before I started grad school. So I went to work for the World Health Organization in Geneva. I'd been doing work there in the summers during my undergraduate work, actually during the spring breaks and during the Christmas breaks as well. And I sort of liked the working environment there. I was doing statistical forecasting for HIV predictions of how it might affect and evolve in different countries and different settings. And I felt like that work was pretty interesting and important. But I wanted to do a time limited thing. So I signed up to do that for a year. And then I knew I would apply to grad school and go to grad school at the end of that year.
It sounds like there's this sort of common thread of healthcare interest all the way through, maybe stemming from your parents. I was kind of curious. So for the viewers here that are maybe trying to make the best out of their college experiences and their studies, do you have any, advice or, how they can make the best use of their time in school?
Yeah, I mean, I think one really great aspect of being in school is that you can try out lots of different things. You can take classes that seem interesting, that aren't necessarily in a fixed curriculum. You have a bunch of electives. So try things that you think are, something you might like, and you might discover you really do like it. Like I took an econ class and ended up taking 13 more. But it's really a good way to sample the world around you in sort of university courses. And the same can be said even if you're not in school, is how can you put yourself in a spot where you can learn something new. A lot of the work I've done over the years, the most interesting work is where you kind of come together with a bunch of people who have different kinds of backgrounds and expertise, and you all collectively kind of do something that none of you could do individually. And also some of their expertise rubs off on you and hopefully vice versa. And then you kind of go on your merry way, but now you've got a bit of additional sort of ways of looking at problems or expertise.
Right. Nice. And so Jessica kind of teased this already, but then coming out of university or graduate school, you were exploring other positions, both in academia and industry. What was that process like? And did you have certain aspirations at that point where you wanted to go into academia, and how did you adjust?
Yeah, so I was a little unsure. My wife also has a PhD in a different field, and we were looking for academic jobs in the same, ideally, school or city.
Okay.
That's always a challenging set of constraints. It's called
Yes.
the two-body problem. And so, we ended up finding actually academic jobs in a university that, wasn't a great department for me, was a great department for her. And we just had our older daughter, and so she was now a year and a half. And I think given that, we decided my wife wanted to take a little time off and spend more time with our daughter before she got into a full-time job. And so we decided to look at what my best, most desirable job was, which was in the Bay Area. I'd also interviewed at a bunch of different industrial research labs, and that was kind of a trade-off I was making, is academics versus industrial research. And I kind of actually preferred the industrial research setting because I felt like I liked building things myself. And I felt like as a professor, you kind of end up not being able to do that as much because you're really trying to do 3 jobs at once.
Right. Yeah.
And so I ended up going to Digital Equipment Corporation, had a small research lab in Palo Alto called the Western Research Lab. They actually had another research lab 2 blocks away called the Systems Research Center.
Right.
But I really liked the fact that it was a small lab with like 20 or 25 researchers, but it was doing lots of different things. A lot of the other research labs were very big places, like IBM Research, where I interviewed, had like 1,000 people in one building doing lots of, with 30 people doing stuff that was very directly in line with the stuff I'd done on my thesis. I would then be the 31st person doing stuff in that group. I'm like, I'm kind of tired of my thesis. I'd rather, a bunch of people doing a lot of different things, and you can kind of dive into different ones as you saw fit.
Yeah. So you already mentioned that first job that you did land was with DEC. Backing up a little bit, how did you land that job? What was there anything that you felt like in your credentials through your studies that really helped you nail that job?
I mean, I think, that interview was basically, I'd published a bunch of papers in grad school, so presumably they knew my background from that. I gave a talk to the whole research lab, like an hour-long talk or something about my thesis research. And then I had probably 10 interviews that were usually 2-on-1 kind of interviews.
Yeah.
Where we just talk about either people would follow up on some aspect of what I'd discussed in my talk, or they would ask me questions about other things, or they'd tell me about their research and we'd have a conversation around it. Kind of a very individualized thing. No writing code on whiteboards. They assumed I could code. But those interviews are fun because you just have technical conversations. And so they often kind of go off in interesting directions. That's kind of how I pattern my own interviewing style, is that kind of free form technical discussion, as if we're colleagues and we're talking about something, some problem. I like to ask nice, vague, open-ended questions and see where that takes us.
Yeah. And then you also talked a little bit about, there being sort of a diversity in different types of projects at DEC. Can you talk a little bit about maybe like one of your early ones, or things that were one that was particularly interesting to you when you were there?
Yeah. So, one of the first projects I got involved in was a project on sort of very low overhead continuous profiling of computer systems. So basically, could you build like a little background thing that's always gathering profiles of where time is going in a computer, and would profile everything? It would profile the operating system, it would profile device drivers, it would profile different application user level processes that are running on the system, and could give you a glimpse at all times of what's happening and what things are worth optimizing. And would do so with very low overhead. So like we were aiming for less than 0.5% overhead overall in the system. And the way it worked is it basically would periodically wake up and it would sample, where is the program counter now? What are we doing? And then we would record all those samples in sort of an aggregated hash table, and then periodically write those out to disk. Then we built a bunch of tools to analyze those profiles, those samples, and give you a higher level view of, which things are encountering a lot of cache misses, which things are encountering, branch mispredicts and things like that. And it was a pretty useful tool, and it was a fun project because it had a lot of different kinds of people involved in it. Some people had hardware expertise. Some had sort of operating system expertise. I was more of a compiler background from my grad school work.
Yeah. That sounds like also great preparation for what I know Google teams look like here. And that sort of leads me to sort of the next large phase of your career here. So how did you end up at Google? Can you talk a little bit about that transition that brought you here and what you were looking for at that point, that sort of transitionary point?
Sure. So I really liked the local research lab environment at DEC. The 25 or 30 local colleagues and sister colleagues in the lab 2 blocks away were great. What I found a bit difficult there was DEC's research labs were set up as fairly isolated things, and getting your work out into real sort of use involved finding the right product team that could take advantage of whatever you've done, convincing them that what you've done was useful and important. With the kind of mass of the company being almost all around Boston, we were a bit isolated, so sometimes you wouldn't even know who are the right people to go talk to. And often they'd say, oh yeah, that's really interesting. We can slot your work in for our roadmap that's coming out 2.5 years from now. And I just felt like that was a little bit slow and frustrating in terms of how my work would directly impact people. So I said, oh, well, I should probably try a startup at some point since I live in Silicon Valley. And I would know I would have the ability to have my work more directly used by people. And so I was looking for a startup that would have a set of interesting problems, but would also, have an outlet to have my work not just be prototypes and writing papers, but more concrete things that actually went into real production systems.
Yeah, that's interesting. And actually, I have an associated question from one of the viewers on our stream. Andrew Kim is asking, how do data science teams at big tech giants like Google operate differently from a team at a startup? And how should an aspiring data scientist focus on skill sets change based on that environment? Tech giant versus startup, since you've kind of seen the life cycle of that growth that person wants to work in.
Right. I think at a small company, there aren't as clearly defined roles. So people kind of pitch in and do whatever is needed. And so that is a certain mindset and set of skills, the ability to kind of dive into lots of different problems. As companies get bigger and more established, you have the ability to have a sort of more focused set of people looking at a particular set of problems. And that sometimes can add a bit of depth. You can then say, okay, what is the right thing to do here? As opposed to, what do we need to do by Tuesday so our site doesn't melt?
Yeah.
And I think that's a somewhat different working style. I enjoy both of those working styles actually. Yeah. So it's kind of hard to choose. I kind of like the urgency and the frenetic activity that sometimes happens when you're trying to get a bunch of stuff done and everyone's just kind of coming together.
Yep.
On the other hand, a bit more thoughtful organization of people thinking through a set of issues in a bit more comprehensive way is also quite useful.
Yeah. And you kind of touched on this just now when you're talking a little bit about teams and the sort of differences between working as an individual contributor and collaborative opportunities. I think that this is probably also quite pronounced for both software engineers and data scientists. What sort of advice do you have for people trying to balance those two sides of this type of work?
Yeah, so for me, for quite a long time in my career, I never managed anyone. So I was always an individual contributor, and I would just work together with a relatively small set of people on particular problems. And then I would kind of work on that for, a month or a few months or something like that. And then I would go off and find another problem, sometimes with the same set of people or a lot of the same people, and sometimes with a completely different set of people. In the last 5 or so years, I sort of started to manage people, which was kind of a different thing for me. It's kind of stretching me in new ways. Um, the basic story behind that is we'd started the Google Brain project, which is basically this project to investigate very large scale neural networks using lots of computation to tackle a bunch of problems in computer vision, speech recognition, and language understanding. And it was kind of jointly founded by myself, Andrew Ng, and Greg Corrado. And it was located in, some of the people were in Google X, and I was not, but I was sitting over in the Google X building. It's now called X, but at that time it was called Google X. And unlike a lot of Google X projects, which are kind of like, let's launch a bunch of big balloons and fly them around the world and do stuff, ours was very much of a software project that was very relevant to kind of lots of core Google teams. And so it didn't really make sense for us to be off on the edge of campus in this kind of Google X environment. And so we sort of graduated into Google proper, into Google Research, focused on building these tools out and interacting with a lot of teams to get our work out into real products. And as part of that, when the team was moved, there were about 7 people, and there was no obvious person to manage them.
Okay.
Either like Alan Eustace, who was head of all of research at the time, I was reporting to him, and it didn't make sense for those people to report directly to Alan. So I'm like, oh, I can probably manage them until you find someone else.
Yeah. Okay. And so that's kind of grown you a little bit into this sort of managerial piece. Yeah.
Yeah. I don't think he ever looked. So for anyone else. And so over time, as our team grew, I started to have, 20 people reporting to me. And then I'm like, oh, well, it probably makes sense to have someone else manage some of these people directly. And then it eventually became, 100 people, 300 people, 500 people. And then my previous boss, John Andrea, was leading all of search and research, and he decided to go to Apple. And so he said, oh, you should take on all of research. I'm like, so anyway, I have a pretty large organization that I'm managing, but I'm still finding time to do hands-on work. So I try to divide my time so that I have 2 days a week to write code with, a handful of people. In some project, I think, whatever project I think is really interesting and important. And then the rest of my time is how do I steer the larger org to make sure that we do impactful research, that we're focused on the right things, that we have a happy and healthy working environment, that, we're getting collaborations with product teams and other teams going.
Great. And, along the way, you've talked a little bit about how some of the things that you've done have evolved. I thought it might be interesting to talk a little bit about sort of mentorship. And this is kind of inspired by another viewer, Subaham. He says that, a lot of data scientists have said that it's helpful to have someone more experienced in your field to learn from, and having a mentor can really smooth the learning process. Could you share something about people who might have inspired you and mentored you in your career?
Sure. Obviously, going to a lot of schools, I had a lot of teachers sort of pre-college, and a few of those stick out. There was my 4th grade teacher who recognized that I'd run out of books in the elementary school library and got me special permission to trot off to the middle school library and get more interesting books. There was a great math teacher in high school who kind of just supported my interest in math and computing. My undergraduate advisor, Vipin Kumar, who taught that course in parallel and distributed computing and then sort of mentored my undergraduate research work, is a strong influence. A lot of that is why I decided to go to grad school, because I got a bit of a taste of research there. My PhD advisor, Craig Chambers, taught me a ton of stuff. He was a relatively new faculty member, so he'd arrived as a faculty member the same year I arrived as a grad student, and I was his first PhD student. And so, me and three other students kind of in the group at the time. And he were like basically building this optimizing compiler together and exploring interesting work in that space. And we had a great time doing that. You know, he was stressed out about getting tenure, so we were all excited about publishing our work and doing interesting research. And then, you know, my longtime colleague Sanjay Gemawat and I, who I first met when I was working at Digital, and he was also at Digital Equipment's research labs. He was at the lab 2 blocks apart, so I would go work with him and get gelato on the way because it was a good gelato store halfway between us. So Sanjay and I have actually had a really long working relationship, and you know, we, I think, complement each other's strengths and weaknesses really well. So he has this incredibly logical and clear way of thinking, and I have this kind of frenetic, like, oh, let's do something in this direction, and I think, you know, he has this ability to design like the clearest APIs I've ever seen, whereas I kind of like throw something together and that'll probably work. And he kind of stares at it. He's like, oh, you probably don't need all these things. What if we did that? And I think we're a really good kind of combo together. And we often pair program together, sitting at one keyboard. He usually types because he's picky about spacing. I prop my feet up on the desk and we actually like work through, you know, a problem over a period of several hours and then figure out the next thing to do. And that works quite effectively for us. And then as I've gotten more into machine learning, you know, I think there's a lot of people at Google who have much more knowledge about machine learning than I do. And I have more of a systems perspective. How do you actually build large scale computer systems to do things? And so often it's a little bit less about mentor-mentee, but really more about coming together as a team where some people in the team have more machine learning experience and others have more of a systems software system building experience, and collectively we put things together. So I've like learned a lot initially from Andrew Ng when he was here, and then Jeff Hinton, who came as a visiting researcher for about 6 months, I think, in 2012. Funny story, he actually, the visiting researchers somehow end up in the same category as interns at Google. So he was my intern. But I've learned a ton from Jeff over the years about like how he approaches thinking about machine learning problems. And then he went off back to University of Toronto, and then he and a couple of students formed a company that Google acquired. And so he's now been with Google since 2014, I think, and I've continued to learn a lot from him. So it's really about getting yourself in situations where you're working on a set of problems where all different kinds of expertise need to come together, and you can kind of collaborate with people who know things you don't and work on those things together.
Yeah, it sounds like you've really been able to make fruitful or take advantage of sort of these relationships in ways that have enriched yourself as well as the work that you're working on. Curious to hear about, you know, now looking sort of retrospectively at your career so far, sort of what skills do you think that new data scientists, so people maybe coming out of college with degrees, should be looking to build in order to, you know, get to advance their career?
Yeah, I mean, it's certainly exciting times in the field of machine learning. I think it's obvious that this kind of work is going to influence not just computer science or some narrow part of computer science, but really is going to influence nearly every field of endeavor in some way. Mm-hmm. And so I think obviously it's really good to have strong fundamental understanding of you know, how to write programs, how to think about machine learning problems, what are different machine learning algorithms that are commonly used, but also kind of how computers work. You know, really will find it very helpful, even if you're operating at a very high level of abstraction, to think about what that actually means in terms of what you're asking the computer to do, right? And are you asking it to transfer gigabytes of data over the network, or are you asking it to do something relatively lightweight? How do caches work? How do branch predictors work? How is it that GPUs or sort of other kinds of accelerators are better for certain kinds of computations than traditional CPUs, and why? These are all kinds of things that if they're in the back of your head, you can be thinking about them as you're applying computation to solve different problems. Yeah. And then I think another area that's really kind of an important thing is if you have those skills, but then have skills in another discipline or knowledge of another discipline. So often we're seeing, for example, machine learning applied to healthcare problems,
right?
Or applied to neuroscience problems or quantum chemistry related problems. And maybe you don't have deep expertise in there, but being able to dive into how might machine learning apply to this quantum chemistry problem with a quantum chemist is kind of the vocabulary you want to be able to have and the kind of work you want to be able to do.
Yeah. And I mean, machine learning is also evolving so rapidly. Techniques are coming about so quickly. Actually, last week, we held a user conference, Kaggle Days, and Quackley's AutoML team, they actually competed in a competition on day 2 using AutoML. It's kind of so forefront of mind for me is, how are things like this technology, what are the implications of this type of AutoML technology for maybe the types of skills that, or how skills are changing, and what is important for data scientists to acquire? Do you think that it is changing those skill sets in some way?
Yeah, I mean, the way I view tools like AutoML is that, when you're solving a machine learning problem, there's a lot of things up front. There's a lot of things you kind of do lots of experimentation to figure out based on sort of quantitative results of those experiments. And often there's this iteration cycle of like, I run a bunch of experiments, I look at the results of those experiments, these 7 are promising, these 30 didn't work out. I should do a bunch more experiments in the rough area of the 7, maybe with some additional kinds of derived experiments that I now want to do based on the results of that whole set of experiments I ran initially. And then you iterate. Yeah. And, I think one of the real benefits of techniques like AutoML is that they can take some of what humans are doing, data scientists or machine learning experts, and turn that into an iterative process that can be automated. And so this really gives you a bigger toolkit, a better tool to tackle more problems or have the computer work with you to solve the problem in a better way than either one of you could do individually. So it's not that we're not going to need human insight into how to tackle some of these machine learning problems. It's that the kind of drudgery part of that, where you're automating, where you're running experiments, looking at the results at like Friday night at 7, like, okay, what are the next set of experiments I should start up to run overnight, and then waking up to look at them on Saturday morning. Humans should not really be doing that if you can have an automated system that can do that. Instead, you have much higher level insights that humans are guiding these tools to say, okay, tools, why don't you go off and run 20,000 experiments for me and report back, which 10 were the best. And then I can focus on that outcome and use that in the next set of things I'm going to do.
Well, I think tens of thousands of viewers just breathed a sigh of relief that their jobs are still intact. So thank you.
I have a slightly different way of viewing. So the AutoML tools we have today can't come up with completely crazy new techniques necessarily. They can come up with new architectures in some search space that a human has defined. And that search space can be super big. Like if it's 10 to the 30th elements in size, that sort of works okay. If it's 10 to the 60th, the AutoML techniques kind of break down because that's too big a search space. But the way I would think about it is, suppose you have an idea for a new machine learning, component or an algorithm or a kind of approach to tackle a machine learning problem. If you were doing this manually, you would kind of try this out on a few problems. If it's promising, then you might write a paper, try it on a few more problems, tell your friends. Your friends would then say, oh yeah, this thing worked great in that problem. That sounds similar to this. And it would take kind of a while to spread around the community. Now the community's pretty good at picking up new ideas quickly. But imagine instead you had a world where you have a new idea, you could insert it into a system, and overnight some system would explore that new idea by adding it to the search space for thousands of problems, and could give you a report in the morning saying, okay, well, your new thing wasn't used at all in these 900 problems because it didn't seem useful. But in these 12 problems, it was pretty useful, and we used it in this way, and it actually improved accuracy by this amount. That would be much more useful as a tool. Now, it's obviously computationally hard to take your new idea and try it on all machine learning problems in the world.
Right.
But that's like a good directional, aspirational thing to be able to think about.
Sure. And I guess piggybacking on that, what new opportunities do you see growing in the field? Is it simply application across other disciplines, or are there other larger advancements that you see coming down the pipe?
Well, I think one thing I'm particularly excited about is something like the project I'm sort of working on myself with a few other people, is to think about how can we build systems that solve many tasks at the same time using a single model. So we know that multitask learning at kind of a small scale, like often people will do multitask learning of like 4 or 5 kind of related tasks. Or sometimes they'll do transfer learning where you train a model in ImageNet, and then you have your little data set of mushrooms, and you then fine tune on the mushrooms using the model that was originally trained on a much larger set of images. But that's kind of not as ambitious as I feel like we should be doing. We should be essentially thinking about how can we train a single model on all the problems we care about, right? Where that model should have very large capacity because it needs to remember, everything about all the machine learning problems we care about. It should be sparsely activated. So it might have different pieces of the model that are good at different things. And, the part of the model that's really good at detecting, images of mushrooms probably shouldn't be activated when you're looking at text about Shakespeare. But there should be another part of the model that's very good at, poetry and Shakespearean text and is active for that. And the routing in this system should be learned so that you learn kind of pathways through this model that for a particular example or task kind of identify the right pieces of this very large model that are useful for this new task or that you're now trying to solve. And so that different pieces of this model can be shared across related tasks or related examples.
Interesting. We've had actually a lot of questions around the theme of sort of MOOCs and sort of non-traditional, people who haven't gone and gotten their masters and PhDs. So from Sanyam Bhutani, the question was asked, can you envision a MOOC educated person working on cutting edge ML projects? How can a person who didn't go through graduate school develop a competent profile?
Right. I mean, so definitely it's possible. I mean, I think MOOCs are interesting. Like they seem to work very well for people who are self-motivated. I think but there's definitely tons and tons of interesting educational content on the internet now. So there's like a real advantage compared to people 20 or 30 years ago where there wasn't this really rich set of content on almost anything you wanted to learn about. I think, it's important to have the fundamental background. MOOCs can give you that. It's also important to kind of practice your craft. So by finding interesting problems, Kaggle contests are probably a good way to do this. Working in a job that gives you experience with this is also a really good way if you can figure out a way to arrange that. One of the things we've been doing in our group is we have a residency program, an AI residency program, where we get applicants from lots of different kinds of backgrounds. Some people have PhDs in computer science or machine learning, but a lot of people are coming from a different field. Maybe they have a master's in physics and they kind of got a taste of machine learning when they were doing that, but now they realize that they want to do machine learning work. How can they switch into that career? And we've had pretty good luck taking sort of the people we accept into our residency program, and regardless of their background, turning them into either kind of research software engineers or research scientists in our group that are doing kind of cutting edge machine learning work.
Yeah. And so you kind of mentioned this before about how your interview style works and how it's kind of similar to what you might have experienced. But as someone who's probably interviewed many people for roles on your teams, what do you look for?
I mean, first and foremost, I look for, is this someone I would want as a colleague, right? Are they have a conversation?
Yeah.
Is that conversation flowing well? Are they bringing up interesting things I hadn't thought of? If I steer it in a particular direction, do they seem to know what direction that's going? Obviously they're not going to necessarily know everything, but I really treat it more as a conversation among colleagues that I can assess, rather than you must write code, reverse a linked list on a whiteboard and stand awkwardly by the whiteboard as your editor. Kind of thing. And I really like open-ended questions where a variety of different kinds of insights can come to play. So one question I've asked in the past is, suppose you wanted to speed up browsing of the web. And you can install whatever software you want in Google data centers and in the user's computer. What kinds of things would make sense? And then that discussion can go off into lots of directions. Can talk about fetching, can talk about compression, can talk about, sending deltas of pages that don't change very much every time you reload them. Can talk about, identifying which pages a user is likely to visit given the page they're on now, so that you can actually figure out how to prefetch things appropriately. Can go in dozens of directions, and I'm happy to talk about any of them.
Yeah. And so I thought that, as we're kind of drawing to the close of the Q&A, time has flown by so quickly. I thought it might be interesting to hear, so this is a question actually from Timothy Yee. If you weren't working at Google, doing what you're doing now, where would you want to work? What would you like to see accomplished in your lifetime?
Yeah, good question. I'm happy where I am.
You can't imagine a life without Google, can you?
I mean, I think the thing I really value the most is three things, three qualities I really like. One is I like working on interesting technical problems. I like working with people who know things that I don't. And then I like when the work that we do together can have impact in the world. So those three things together are what motivate me and excite me. I think there's a lot of opportunity to build more and more advanced machine learning systems that can solve, much more than the kind of simple, well-defined tasks that we've got today. I think there's huge opportunities for machine learning to really make impact in, things that really matter in people's lives, like giving them better healthcare, helping them have kind of individualized tutoring so that everyone gets a higher quality education. I think these are the kinds of things that excite me, because those are the ones where there's real technical problems and where the outcomes really matter.
Yeah, absolutely. And so you kind of mentioned a little bit about, your personal life through your childhood. I actually have a somewhat of a personal question as well. I've learned that, you and I both share something in common. It's that we both have daughters. And I think constantly about their opportunities, especially, looking back at sort of the underrepresentation that I might have experienced growing up through my career. What do you think needs to happen to promote more representation and inclusiveness in machine learning?
Yeah, I mean, this is like something I care about quite deeply. My older daughter is actually in the machine learning field. She's in graduate school, and she doesn't have a lot of female students in her cohort, and obviously it'd be better if she had more. I think, one of the things is making sure that at the earliest ages of people starting to get interested in computers, that we sort of inspire everyone and expose everyone to the possibilities of what can computing do and how is that an interesting career path in ways that appeal to everyone. I think other ways are making sure that the culture of respect and inclusion in our working environments is inclusive for everyone, not just people who are from a majority background. And I think what you really want is for the field of machine learning, which is obviously impacting a lot of things in the world, products used by billions of people all over the world. You want the people building those products to reflect the diversity of people using those products. And that's something that we need to be cognizant of. Is not just a gender issue, it's a racial diversity issue, it's a socioeconomic diversity issue. People who have laptops at home and parents who are in a technology field are inherently at an advantage relative to people who maybe don't have those things in their home life growing up. And I think it's really important that these things, the people are not at a disadvantage to the extent we can arrange for that.
Yeah, well, thank you. That's actually quite a nice note to close on. And we have reached the ending point of our conversation. It's been thrilling for me to speak with you. So thank you so much for joining us. And I hope that our audience also enjoyed and were able to take away a few tidbits of knowledge from a veteran. So thank you so much, Jeff. Yeah. And I think back to Jessica.
Thanks very much. Thank you for the conversation, Julia.
Yes, likewise.
And with that, CareerCon Day 2 has now come to a close. We are so grateful for all of you that have tuned in today, and we hope you took home many new learnings related to getting noticed. What was the most inspiring or surprising thing you learned today? Let us know by posting your thoughts on social media, and be sure to include the hashtag CareerCon 2019 for a chance to win Kaggle swag. Tomorrow, we will start our last day of CareerCon at 9 a.m. PST as usual. Our final theme of CareerCon is getting the job, and we have an exciting lineup including part 3 of Rachel's API workshop, a behind-the-scenes look at data science interviews with a hiring manager, a So You Want to Become a Data Scientist crash course for non-engineers, and near the end of the day, a digital career fair on our CareerCon Slack channel. Thank you, and see you all tomorrow.